Okay, folks, I know you're working on the test corrections and hopefully you learned some, but here is the actual answers I was looking for. Whether they're perfectly right, well, that's to be seen, but this is what I was looking for on these guys. Now, the following compound would not act as a Lewis acid. If it would ever act as a Lewis acid, as an acid at all, it is a Lewis acid. So right off the bat, HCO3, it's an acid. It may be an incredibly weak acid, but it's an acid. Water can be both acid or base, so that's not the case. Left with BH3 and CO3 too. This guy was the will not act as a Lewis base from last year's test. So this guy is a Lewis acid because if you think about it, boron has 6 electrons. It wants electrons, so it will act as a Lewis acid. The only thing that will not really is CO3 because it's all electrons. It doesn't need electrons. It will act as a base, but not an acid. Now, determining the pH of a solution. I'm glad I didn't give you more of these, but you split it in half. Mg2 plus. You add hydroxide into its neutral. So Mg2 plus goes to MgOH2. And sulfate, SO4 2 minus, you add 1 proton. And see, is this a strong acid? Is this a strong base? Strong base? No, it's a weak base. This is H2SO4 is a strong acid, but HSO4 is a weak acid. So what I was going for with this one, maybe it wasn't the best one, was that more information should be needed. You need a KB and a Ka to help determine which one of these is stronger. More information needed. If you needed a KSP value, still need more information. Okay, cocaine is an alkaloid, a bitter nitrogen-containing base. pKb of 5.3. What is a pH of 0.15 molar? Solution of this guy. So the rule is that OH minus is equal to the square root of Kb times the base concentration. So first things first, turn my Kb into a pKb into a Kb. So 10 to the negative 5.3 is equal to my Kb. So 10 to the negative 5.3 is 5.012 times 10 to the negative 6. So OH minus concentration is equal to the square root of 5.012 times 10 to the negative 6 times 0.15. So square root that. And you have the OH minus is equal to 8.67 times 10 to the negative 4th. Now, to get pH, you're going to take 14 plus the log of 14 minus the POH. So 14 plus the log of my OH minus. So negative log of that. The PK, the POH is 306. So 14 minus that is, I screwed something up on my math. So, well, the closest I can get on my answer key is, 10.93, which is close enough to A. Okay, so moving on. So apparently the typos are strong in this one. Now, what is the pH of the buffer formed by making this? So pH is Henderson-House spot. pKa plus log of base over acid. First, what's the pKa? Negative log of 4.8 times 10 to the negative 11th is our pKa. That gives you a pKa of 10.31. So 10.31 plus log of the acid over the base, or the base over the acid, 0.15 over 0.85 plus log of 0.15 over 0.85 is 9.56 or 9.57. So solution of lactic acid as a pH of this. Now this was a trick question. pH of this. You did not need this number at all. No matter what, H plus concentration is equal to 10 to the negative pH. So all you had to do is 10 to the negative 2.23, 10 to the negative 2.23 gives you 0.0059. Let's see. Yeah, we're going to throw some of those easy, overly easy trick questions in there. Determine the molarity of this base. So you find where's the equivalence point. Boom. 25 mils of base with 0.25 molar acid. The volume of acid is 18. So you have 25 times molarity of acid equals 0.25 times 18. Your molarity of acid is going to be 0.25 times 18 divided by 25. It's going to be 0.18 molar. I told you this was going to be on the test. Told you don't forget this. If you forgot it, shame on you. What is the pKa? pKa is at half equivalence point. So you find 9. Right there. I only asked for the pKa, not even the P, not even the Ka. So you just say that the pKa is equal to the pH at the half equivalence point. So it's something close to 10.8 pKa. Good enough. Not quite 11. Good enough. Sodium ethoxide is a strongly basic salt of ethanol. What would be the pH of solution when you dissolve 15 grams into a liter of water? So the OH minus concentration is going to be equal to the molarity of this. So we have to take 15 grams divided by sodium, 2 carbons, so 24, 5 hydrogens, and 1 oxygen. 15 divided by what's the molar mass? 24, 5, 16. It's 68. So 15 divided by 68 is something like 0.22 molar. 22 molar. So you would say 14 plus the log of 0.22 would give you your pH. 15 plus log of 0.22 gives you 13.34. Very basic. And then finally on this page, last one on this page, copper 2 oxalate as a KSP. So it's going to split it into copper and oxalate. KSP of 4.43 times 10 to the negative 10th. Well, what molarity would be allowed to dissolve? So KSP for a 1-to-1 is going to be equal to x squared. So to find x, you're just going to have the square root of your KSP. So the square root of 4.43 times 10 to the negative 10th 10th is going to be 2.104 times 10 to the negative 5th. Or number 9. What is the pH of a of 0.8 molar perchlorate? No Ka, so it must be strong acid. So pH is the negative log of 0.8. The negative log of 0.8 is 0.096, which rounds to 0.1. That's 0.1. So D. Now, what is the POH? POH of the buffer made from this. So we have a Ka, so we're going to have to, the pH equals pKa plus log of A minus over HA. So I'm going to just find the pH and then convert it to POH. First, what is the pKa? pKa is negative log of 6.2 times 10 to the negative 10th. And log of 6.2 and 10. The pKa is 9.2, well, 9.21 plus log of 0.73 over 0.25. So 0.73 over 0.25. The pH equals 9.67. So 14 minus 9.67. 9.67 is 4.33. There we go. Moving right along. Another POH problem. What is the POH of 0.5 molar, 0.55 molar methylamine? OH minus is equal to the square root of KB times B. I give you a KB, 4.38 times 10 to the negative 4th. Give you a molarity of the base, 0.55. Square root that to give you OH minus. 4.38 times 10 to the negative 4 times 0.55 gives me the concentration to be 0.0155, and the negative log of that to get me POH. Log of 0.0155 gives me 1.81. That's all you need to do for that one. All you need to do. Which buffer would be used to generate pH of 5.55? So you want a buffer that is plus or minus 1 from the pKa. So find the pKa's of each of these. Negative log of 1.8 times 10 root negative 4. pKa of 3.74. So, nah. So we have, what about 3.5, 10 to the negative 8th? 7.45. I gave you all Ka's. I tried to make it easier. So 6.4 times 10 to the negative 5th. 4.19. Closer, but still too far away. So 1.8. Yeah, just them all. 4.74. That's within one pH unit of 5.5. So that is your best answer. One last POH problem. This is probably the hardest problem. What is the KSP is equal to copper times OH minus squared. So what you, and if copper is X, this is 2X, you have 2X squared. So KSP is equal to 4X cubed. So first you had to find X. First, you had to find X. So to do that, you'd have 4.8 times 10 to the negative 20th divided by 4, and we cube root that whole thing to find X. So 4.8 divided by 4 times 10 root negative 20th, and we cube root that. To cube root that, X is equal to 2.29 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. So OH minus would be 2X. So we double that. OH minus is 4.58 times 10 to the negative 7. Finally, the negative log of OH minus gives us our POH. So negative log of that answer. It is mildly basic with a POH of 6.34. Mildly basic with a pH of 6.34. Not much, but enough. This one, maybe arguably, it's supposed to be just a simple Le Chatelier. Le Chatelier says, the formation of the reaction, what would increase the amount of tetramine copper complex? Removing a product will shift it towards products. Adding a reactant will shift it towards products. HCl would hypothetically remove this guy, reactant. So that's out. Adding water, well, technically water wouldn't really do anything, but it's also adding a product here, so probably not the best. Adding hydroxide might remove some of the water, but that one's kind of iffy. The best answer would probably be adding ammonia. More ammonia is going to cause that to shift to the right. You can maybe argue C, but D is the best answer. 25 mils of 0.2. This is a titration problem. Check where we're at first. 25 mils times 0.2 molar is 10.2 is 5 millimolar. 10 times 0.5 is also 5 millimolar. 5 millimolar minus 5 millimolar is 0. What happens when we run out of moles? You get neutral. It's neutralized. The big equation I gave you for this guy was either negative log of the molarity as, well, in this case, molarity base minus volume base, what times volume base minus molarity acid times volume acid over VA times VB. Or I gave you a version that, so that'd be 14 plus that. I also gave you 14, well, I also gave this negative log of MA times VA minus MB times VB over VA, sorry, that's plus VB. And if neither of those two equations gave you an answer, it's because it's at equilibrium. Neither of those gave you an answer, it's because it's at equilibrium. Well, same situation. Well, 30 times 0.2, that's 6 millimolar. 6 millimolar is greater than 5 millimolar. So I'm going to use this equation for the last one. This was also a typo problem. I am sorry. However, you could still get close. So you have something like 30 times 0.2 minus 10 times 0.5 divided by 30 plus 10. So divided by 40, and then we take the negative log of that, and then we take it from 14. The answer you get is something like 12.39. Clearly not 12.75. I don't know how I got 12.75, but the closest you can get would be that number. That's what I was going for. It's not pH 7. It has to be just beyond that. So last one, set this up. Set this guy up. This was a super challenge. I probably shouldn't have made it so super challenging. Sorry. So split up. This would split up into 3 copper, 2 pluses, and 2 phosphate, 3 minuses. In terms of x, this would be 3x cubed 2x squared. So 3 times 3 cubed is 27x cubed times 4x squared. 27 times 4 is 108. So the proper way to set this up, KSP equals 108 x to the 5th. If I gave you the KSP, you could have found what is x and then what is the amount of copper. However, that was a bit of a challenge. Had you tried it and got something right, I gave you partial credit. But that was the test.